Good afternoon all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the video lecture series on Discrete-Time Fourier Transform. See, empathy. Why do we need DTFT? See, DTFT is to analyze the discrete time signals. Need to analyze periodic frequency spectra of discrete time signals. Real world motivation is used in audio compression, digital filters and DSP systems. See, helps in visualize the sequence pattern from Z domain representation. First, we can apply the sampled signals. We can apply the Fourier transform and then analyze the periodic spectra, visualize sequence pattern, enhance the signal processing. Next one, where DTFT used? It is used in DSP for analysis of discrete sequences, communication, spectrum shaping and channel response, speech and audio, spectral analysis for compression, that is nothing but MP3, codecs, etc. Control system stability check via frequency domain. Is the signal analysis of discrete time Fourier transform. It can be divided into continuous and discrete. Continuous is of periodic and non-periodic. Periodic is of Fourier series. Non-periodic is used to analyze the Fourier transform. In terms of discrete, periodic is nothing but discrete Fourier series. For non-periodic, going to analyze the discrete time Fourier transform and is a transform. Next one, this is the Fourier coefficient representation. First, we can going to analyze from the time domain into frequency domain with the help of Fourier transform. That is nothing but Fourier transform of a function s of t that can be converted into frequency domain, transformation of the time domain into frequency domain with the help of Fourier series coefficients with respect to time and amplitude. And then transformation of periodic samples s of t we can going to analyze with the help of discrete time Fourier transform. The discrete time Fourier transform that can be converted into frequency domain, transformation of both periodic sampling and periodic summation in terms of discrete Fourier transform. FFT is nothing but fast Fourier transform, is used for analyzing the discrete time signals with reduced number of calculations. Next one, discrete time Fourier transform. Discrete time Fourier transform is used for analysis of discrete time signals. It's the process of conversion from the time domain into frequency domain with the help of discrete time. This is the DTFT representation from time domain to frequency domain. See, time domain with respect to n and x of n can be given in terms of discrete time that can be converted into frequency domain in terms of x of e power j omega with respect to omega. Next one, discrete time signals are analyzed with the help of periodic signals. DTFS, discrete time Fourier series, is used for analysis of periodic signals. DTFT, discrete time Fourier transform, is going to analyze both periodic and non-periodic signals. Discrete time Fourier transform describes the spectrum of a discrete time signals. The DTFT of discrete time signal x of n is given as x of omega is equal to summation n is equal to minus infinite to plus infinite x of n into e power minus j omega. Next one, inverse DTFT. X of n is equal to 1 by 2 pi integral over minus pi to plus pi. X of omega is equal to e power j omega n into d omega. Existence of DTFT means DTFT of x of n will converge if x of n is absolutely summable. Summation n is equal to minus infinite to plus infinite. Modulus of x of n should be less than infinite. This is the ideate part, the DTFT constant function. The given function for the unit step function x of n can be given that can be converted into frequency domain with the help of DTFT. With respect to x of omega and omega that can be converted into frequency domain. This is the representation of DTFT and DFT. First, x of n sequence can be given from 0 to n minus 1 with respect to n. That x of n that can be converted into DTFT, discrete time Fourier transform. It can be represented, and also DFT how can be represented in terms of discrete time is represented by 2 pi by n, 0 to 2 pi by n, 2 pi by n to n minus 1. Next one, this is the DTFT for sinusoidal function. See, cos function can be given as sinusoidal function can be given cos omega naught of t while we taking the discrete time Fourier transform of cos omega naught n, that can be converted into frequency domain with the help of minus omega naught to plus omega naught. As the del of n can be functioned is nothing but 1 for n is equal to 0. See, that can be converted into frequency domain, that is nothing but del of omega plus omega naught to del of omega minus omega naught. This is the DTFT impulse function. Del of n is equal to 1 for n is equal to 0, 0 for n should be not equal to 0. The del of n with the converter into frequency domain with respect to x of omega is nothing but minus pi to pi. This is nothing but extent of frequency band in discrete frequency domain. Now we can going to mind map the DTFT for reflection how DTFT helps understand system frequency response, and its how can be applied in a FIR and IAR filter design, audio analysis and communication and modulation. Design a discrete system with a desired spectrum. See, it is used for IAR and FIR filter design, communication modulation, audio analysis and understanding of discrete time Fourier transform. Now we can see the assessment. Define discrete time Fourier transform. Discrete time Fourier transform can be defined as x of omega is equal to summation n is equal to minus infinite to plus infinite x of n into e power minus j omega n. Discrete time signals are analyzed with the help of periodic signals. Discrete time Fourier transform of unit step signal is given by x of omega is equal to 1 divided by 1 minus e power minus j omega. Mention the applications of DTFT. It is used in digital signal processing, communication, audio analysis, etc. The existence of discrete time Fourier transform is given by summation n is equal to minus infinite to plus infinite. Modulus of x of n should be less than infinite. The unit impulse function of DTFT is given as whatever the function unit impulse function means, del of n is equal to 1. Therefore, x of omega is equal to 1. Thank you.